In this video, we will be talking about energy, the different types of energy, and the units relating to energy. In the field of both physics and chemistry, we are often interested in the transfer of energy from one system to another. Often, a physical or chemical change in matter will result in matter either gaining or releasing energy. This energy is the capacity to do work, and work is the action of a force applied across a distance. So for example, you could have a heavy object and pushing on it, move it to a new location. So in this case, you would be working against the force of friction and gravity, depending on if it's flat or going up a hill, but it is a force being applied over a distance. A force is a push or pull on an object. An example of one that we deal with in chemistry is electrostatic force, which is a push or pull on objects that have an electrical charge. One of the fundamental laws that guide our study of energy is the first law of thermodynamics. Essentially, energy of the universe is conserved, and that all matter is going to possess some amount of energy. Energy can be classified either as kinetic or potential. Kinetic energy is energy that is associated with movement. The most common one being kinetic energy is 1/2 mv squared. If we look at the units on kinetic energy, 1/2 wouldn't have units. M is mass. The base SI unit for mass is kilograms. And then velocity is how fast something is traveling. So that's meters per second. If you square it, that is meters per second squared. Putting these all together, you get kilogram meter squared per second squared. This here are the set of base values that make up the derived unit of the joule. Joule is our fundamental unit for energy. Potential energy is energy that is associated with position or composition. In physics, you would have learned that by taking an object, moving it up to a particular height, you are introducing potential energy. So if we had an example of like a 10 kilogram weight at the top of a building, it has high potential energy. And if we give it a little push, that energy gets converted from potential energy into kinetic energy. So it goes from a resting position, uses some of that potential energy from the gravitational pull, converts it into kinetic energy, and then moves down quickly, slams into the ground, and that energy is now converted from kinetic energy into a different form of energy, this time heat and in some cases sound. So energy can be converted from one form to another, either chemical to mechanical, solar to mechanical, mechanical back to chemical, electrical to chemical. There's a whole bunch of different conversions that we can do. And that is one of the key things that we'll be looking at both in the first and second semester of general chemistry. Because we're interested in the transfer of energy, we need to have very specific terms for the objects to which energy is being transferred between. So, going back to our first law of thermodynamics, the energy of the universe is conserved, right? Energy can't be created or destroyed, and all matter possesses energy. So if we're looking at the transfer of energy between two objects, the energy will flow out of one and go into the other. We will use the term system for the particular set of equipment or chemicals or whatever we're interested in. This will be our main focus. The energy from the system can be transferred into the surroundings. So the surroundings would be everything that is not the system. Often we will be looking at the area immediately outside of the system, but as we will see in later chapters, the surroundings can actually have a wider definition than just the immediate outside of the system. So the system is the area or location that we are studying, and the surroundings is the area or location outside of the system. The universe is essentially the system plus what is not the system, which is the surroundings. So the total energy of the universe would be the system plus the surroundings. We will again primarily be focusing on energy coming in and going out of the system. There are two terms for the energy transfer depending on the direction in or out of the system. We have endothermic and exothermic. Endothermic is where there is a heat transfer from the surroundings to the system. The energy of the system increases, whereas the energy of the surroundings decrease. The temperature of the surroundings goes down, where the energy of the system goes up, not necessarily the temperature of the system. Exothermic reactions are where heat is transferred from the system to the surroundings. The energy of the system will decrease and the energy of the surroundings will increase. The temperature of the surroundings will go up. There are a variety of different units that get used with energy. We have the calorie. The unit will be represented with CAL. 1 calorie is the amount of heat needed to raise the temperature of 1 gram of water by 1 degree Celsius. 1 calorie is equal to 4.184 joules of energy. We then have the kilocalorie. This is using the same kilo as the SI unit, so that would be 1,000 calories. 1 kilocalorie is 1,000 calories, or 4,184 joules. This kilocalorie is the same as the dietary calorie. So 1 kilocalorie is a calorie in terms of food. The dietary calorie is written with a capital C as opposed to a lowercase c. The dietary calorie is actually a kilocalorie, but it gets called just a calorie. Then we have the joule, which is the unit that we were talking about before, and this is the primary derived unit in the SI or metric system that is used for handling energy. 1 joule, because it is a derived unit, is based on our base units of kilogram, meter squared, second squared. We could also call it a Newton meter. Often, the amount of energy that we'll be working with is significantly larger than just a joule. In this case, we'll be using kilojoule, which is 1,000 joules, as indicated by our kilo with our SI units. So kilo is 1,000, so this is 1,000 joules. Another one that we will use later on is the kilowatt hour. 1 kilowatt hour is equal to 3.60 times 10 to the 6th joules.